Hello, this is question 3 from the 2018 MAT. Let g of x be the function defined by all of that. So this is another one of these functions where they've split it depending on whether x is greater than 0 or less than 0. And for x not equal to 0, we can write m function of x for the gradient of the chord between these 2 points. So we've got the point when x is 0, which could be in either of these functions because we've got a equal to 0 as part of the inequality, and then just some general point. I wonder if they go through the same spot. That would help if they did. If we put 0 in the top one, then we get 2. If we put 0 in the bottom one, then we get 2. Right, so this is just a fixed point then. This is just 0, 2, and some general point on this compound function. Anyway, right, start off with part 1 then. Sketch the graph y equals g of x between -3 and 3 inclusive. Have we got more negative, more positive? I'm just trying to decide which way to draw the axes. We seem to have more positive than negative on this, so let's just lean a bit in one direction. So we're going from -3 to 3, because when we got -3 in the bottom one here, then we're getting 3 minus 4. So we're getting -1, so we're going through there. And when we put 3 in the top one, we're getting 5. So we're going up here. So that's at -1. So we've got -3, -1, and then we've got a 3, 5 on those points. And we know that both of them are going through here at 2. And then, well, let's just draw out 2 quadratics. So the bottom one is the negative one, which is a negative quadratic that's been moved 3 up and 1 to the left. So it's going to have a peak there at -1, 3. So it's going to look like that. And the other one is a positive quadratic, which has been moved 1 to the right and 1 up. So it's going to have a minimum at 1, 1. Right, so we've got that sort of thing. So it looks a bit like a cubic, but it's not a cubic because we've got 2 quadratics stuck together. Write down expressions for m in the 2 cases of positive and negative x. So, right, well, let's go with a positive one. So if x is greater than or equal to 0, so we're over this side here, which means we've got our top expression. So change in y is going to be where it's going from 2, and then we can take off that function. So we'll have x minus 1 all squared and then take the 1 off. And then that'll be 0 minus x on the bottom. So we're going to have the 2 minus the 1, we're going to take off another 1. So we're just going to have minus x squared plus 2x divided by minus x. So we're getting x minus 2 for that one. And then the other one then, x less than 0, we're doing more or less the same thing. So we're going to have 2 minus 3, then plus x plus 1 all squared divided by minus x. So we're going to have a, well, 2 minus 3 minus 1, then we're adding on 1. So again, all of the, just the straight numbers are disappearing. So we've got an x squared plus 2x over minus x. So minus x minus 2. So they certainly look similar. Show that m of x plus 2 equals x for x is greater than 0. M of x, well, we've just done that. So, and the only thing they've done is knock the equal sign off the inequality. So how is this any, I mean, that is what we've done here. M function of x plus 2 is equal to x. Okay, unless I'm missing some in there. But that seems fairly obvious off of that. And what is the value of m of x plus 2 when x is less than 0? Well, we've done that as well. It's minus x. Okay. M of x plus 2 when x is less than 0. Yeah, minus x. Right, that seems bewilderingly obvious, that part of the question. Anyway, I don't know. I don't think I'm missing anything. Anyway, part 4. Explain why g has derivative minus 2 at 0. Explain why g has derivative minus 2 at 0. Right, so they're saying we can't use m of x. They've said it in the question. We can't just put m of x. We can't put x is 0 into m of x, which is a bit annoying because they both give minus 2 when we put x is 0 in there. So I suppose this is going to be the limit of it. I suppose we need to get into that terminology, really, don't we? The limit of each one of these. Right. Let's get a new sheet up. So we can say for both x being less than 0 and x being greater than 0, the limit as x tends to 0 of m of x is minus 2, and m of x, so that is because we're just moving in. If you think of what this chord is doing, we're taking, with a negative bit, we've got some fixed point there, we're drawing these chords in, and the chords are getting closer and closer and closer to that point. And this is the gradient at x equals 0. At x equals 0. Right. So yeah, I suppose you might want to put on something like, because the chord approaches the gradient as x approaches 0. Right, okay. Part 5. Suppose that p less than q and that h of x is a cubic with a maximum at x is p and a minimum at x is q. Show that the gradient of the function is less than 0 between p and q. Right, okay, well that'd be easy enough. I mean, that's just describing a cubic curve. So if p is less than q, then we've got a positive cubic, so which is going to look like that. So we got a maximum here at p, we got a minimum here at q, and the gradient between a maximum and a minimum is negative. Therefore, h dash of x is less than 0. Right, that was fine. Suppose that c and d are real numbers. There is a cubic with a maximum x is minus 1, minimum x is 1. Right, so what we've just done, such that that's the gradient and that is d. Show that c is greater than 0 and find a formula for that function. Right, and that shouldn't be too difficult either, I don't think. Well, we can see this straight away. So we know that, how are we going to put this? So if maximum at x equals minus 1, you could put in brackets, I suppose, equals p, and min at x equals 1, which we can say is equal to q, then this is from part, what was the previous 5? We've got that h dash of 0 is between p and q and is less than 0. Therefore, minus 3c is less than 0. Therefore, c is less than 0. Greater than 0. Less than 0. Greater than 0. Cool. Right, find a formula for this particular cubic. Right, so let's go to a general cubic then. So we could say that h function of x is equal to ax cubed plus bx squared plus, I can't use c, can I? Or d, yeah, D is H. Oh, well, D is still going to be D. Yeah, let's call that E then. Okay, a little bit out of order, but EX plus D, and that D is D because H0 is equal to D. So we've got that, so that's okay. So H dash of X is going to be 3AX squared plus 2BX plus E, which means that E then is going to be minus 3C. So E is minus 3C because we know that is H dash of 0. So we got what E is. And we also know that that's going to be 0 when we put in minus 1 and 1. So H dash of 1 equals 0, which equals 3A plus 2B minus 3C. And we've got H dash of minus 1 is equal to 0. So that is 3A minus 2B minus 3C. All right, so B's got to be 0. B equals 0 because it hasn't made any difference to these. And A is going to be equal to C. So all in all, let's just write it down the bottom over here on the left, kind of weaving around the screen, but still. We've got H of X is going to be CX cubed. We've got no B. Then we've got minus 3CX plus D. Right, so that is that. Last part. Right, hopefully it's going to be very quick because I've got hardly any space left. Show that there are no values of C and D such that the graphs y equals G of X and y equals H of X are the same, so that there is no cubic that is going to actually overlap. We can't put a cubic on top of those two quadratics that are stuck together. Maybe let's try out some values and hopefully we'll get a contradiction in these C's and D's. So let's try this out then. I might be able to squeeze this in then. So let's do X, let's do G of X. If I do it as a little table, H of X, then let's start at minus 3, minus 2, minus 1, 0. Let's just go up. So, well, we know at 0 it's 2, and that's D. So we've got that D is equal to 2. So at minus 1, for G of X at minus 1, we are getting 3. Because we just got 3 minus 0 from up here. And H of X at minus 1 is going to be, my word, right, what we got here? We've got minus C plus 3C, so 2C plus D. 2C plus D. Right, so they could be consistent. We can then say, well, C is a half then off of that. So we've got D equals 2. We've then got C is equal to half. So hopefully if we put in some more numbers, we'll see that this has got to contradict and it doesn't actually work. So we'll put minus 2 in then. So that would be, what are we going to get there? 3. Well, we'll forget about the 3. So we've got minus 2 plus 1 is minus 1. Square it, so we get 2. And in this one, for minus 2, we're getting minus 8C plus 6C. So minus 2C plus D. So that would mean that C is equal to 0. So contradict. Right, okay, you might want to flesh out that a little bit at the bottom, put a full sentence just saying, you know, we can't get values of C and D that satisfy all of these values. I mean, we can't even satisfy those 3 values. So if we can't get a cubic that's going through those 3 points, we're not going to get it. Well, I say 3 points, it's also going through that maximum and minimum point as well. So we fixed numerous points now. Now we've got at least 5 points have been fixed there, but we can't draw a cubic through those 5 points. Well, clearly it doesn't match up with the quadratics. Well, that was an interesting question, that one. It was just a little strange in the middle for parts 3 and 4 that they asked, well, part 3, and maybe not so much with part 4. Part 4, we did have to talk about limits. Part 3 was weirdly obvious. I don't know why they either, if they put it as part 2, it might have felt more natural rather than having it as its own part of the question. I don't know. But overall, yeah, that one was fine. Not that remarkable a question, really.